Hello friends, today's question. A block of mass m1 is placed on a smooth ground over which another mass m2 is placed. Friction coefficient between m1 and m2 is mu. Now a time varying horizontal external force F is equal to bt is applied on m2. Find the acceleration of the block with time and plot acceleration versus time graphs for both blocks. So the figure is given like this. We have a smooth surface on which a block having mass m1 is placed and above which a block of mass m2 is placed, and on this m2 a force F which is equal to bt is being applied. The coefficient of friction between m1 and m2, it is given as mu, and there is no friction between the plane surface and m1. So in this case, let us assume first of all that both blocks are moving together with acceleration a. Let both blocks m1 and m2 move together with acceleration a. Okay. Therefore, we can say that our acceleration a will be equal to applied force F divided by m1 plus m2, and if you put the value of F, which is bt, so this will be bt divided by m1 plus m2. Now let us draw the individual diagrams or the free body diagram, which will help us in further analysis. So this is m2 and this is our m1. A horizontal force F is being applied on m2. Now this m2 will try to force m1 to move toward right because of the friction, and let us call that as Fr, and there will be equal and opposite Fr that will be acting on m2 itself. There will be a m2 G acting for m2, and there will be a normal, let us call that n2 on m2. So based on this, we can say our Fr will be equal to mu n2, and Fr, if you put n2 which is equal to m2g, so this will be mu m2g. So this is our frictional force which will be acting on m1 as well as m2. So we can say for block m1, it is moving toward, it is having an acceleration of, let me redraw it here. So this is our m1. The force which is acting on it is Fr, and it is moving with the acceleration a towards right. So from here we can say that our Fr will be equal to m1 into a. We already know a, so put it here, we get m1 bt divided by m1 plus m2. Now we can find out the sliding condition. So you can say that for sliding condition, we can have that our Fr, which is given as m1bt divided by m1 plus m2, we can say that our m1bt divided by m1 plus m2 will be equal to mu m2g. From here we can find out our value of t. So t will be coming equal to as mu g divided by b, and this will be m2 multiplied by m1 plus m2 and divided by m1. Let us suppose this entire value is equal to t naught. This entire value is equal to t naught. So now we are going to have two conditions. Condition first, condition 1, which states that if this t is less than t naught, if t is less than t naught, then under this condition both blocks move together. Both blocks move together, and we have condition second, which states that t is greater than t naught. So under this condition they move separately. They move separately. And if they are moving together, then we can say the acceleration will be equal to a. Acceleration will be a, and if they move separately, let us find out the acceleration. We can say for block m1, and if it's moving separately, okay, let us do it for m2 first. So this is our m2. Now it is having an acceleration of a2, a force F is being applied, and we have Fr in the opposite direction. So we can say that our F minus Fr will be equal to m2 a2, and we already know value of F is bt, okay, and we all know value of Fr, so we put it here, we get a2 is equal to bt minus mu m2g divided by m2. This is the value of acceleration for m2, and now we write for block m1. Okay, so this is our m1 Fr, and we assume that it is moving with the acceleration of a1. So from here we can say that our Fr is equal to m a1. We already know value of Fr, so we can write that a1 is equal to mu m2g divided by m1. This is our value of acceleration for a1, and this is our a2. Now we can plot the graph for both m1 as well as m2, acceleration graph. So you can say for mass m1, so this is our time, and this is our acceleration, that is our a1. Now this graph will be plotted for two conditions. First is, for first condition, t is less than t naught. So under this condition there is a common acceleration a, which is given by bt, m1 bt divided by, sorry, this is not acceleration. Acceleration is given by bt divided by m1 plus m2. Okay. This is a common acceleration a. So it means with respect to time, this is going to have a, let us divide this graph into two parts. This is our t naught. So up till t naught there will be almost a rise linearly, and this angle of theta. Okay. And for second case, for t greater than t naught, the acceleration is given as a1, and a1 is our mu m2g upon m1, and this is time dependent, so this will be a constant. Okay, so you can say this will be our acceleration a1, and this value will be given as mu m2g divided by m1. Similarly, we can draw for mass m2. So you can say for mass m2, once again we are going to have, this is the time and this is acceleration a2, and divide this into t naught, and we have it in two parts. T is less than t naught in case the acceleration is given as bt divided by m1 plus m2. So this is same as the previous one. This angle is theta, and for the second part we have, for t is greater than t naught, the acceleration is given as a2, which is equal to bt minus mu m2g divided by m2. So here there will be an increase in the slope like this, and let us suppose this angle is given as theta 1. So these are the graph for acceleration, and we can also write the value of theta. So here we can say that our theta is equal to tangent inverse of b m1 plus m2. Here theta will be same as the previous one, and we can write the equation for theta. We can say so the equation for theta will be same as the previous one, which was tangent inverse b m1 plus m2, and for theta 1, we can have the equation as tangent inverse b upon m2. So these are the equations as well as graph for both m1 and m2, which are driven by a force bt, and that is time dependent. So these are the value of theta, which is same as the previous this one, and there is a slope of theta 1, which is given as tangent inverse b upon m2. So this completes the question. Thank you.